So give him a warm welcome.
Okay. Thank you. Thank you, Seth. Hello, everyone. My name is Simeon, and I'm a 3D artist and V-Ray Master Trainer at Chaos Group. Today, I'm going to show you short VFX workshop, VFX and animation workshop, specifically designed for these two purposes. I'll try to keep it well organized, and I'm going to show you real production examples of what's going on in a 3D artist's daily workflow. So I hope you're as excited as me. I'm very glad to see that many people here, and it feels great to be here. So let's start. One last thing I wanted to show you. First of all, I'm going to start with you have forms that you can fill in, and you'll be participating in a draw at the end of this presentation for a couple of those awesome t-shirts, V-Ray t-shirts, and one of you will be very lucky to win a V-Ray license. So just make sure you fill in these forms, and at the end of the presentation we are going to collect them. I'm going to start up with the latest V-Ray demo reel. It's for the VFX industry, so you can, if you haven't seen it, you can get an idea of what V-Ray can do. Can we have some sound, please? Okay, so probably you recognize some of the shows and movies there. Today's workshop is going to be oriented towards VFX and animation. However, if you're welcome to come later at our stand where I can make where I can show you character workshop, character design and rendering workshop, and spend more times with each and every one of you individually. So let's start. This is the shot that we're going to make today, or rather I'm going to explain how I did that. What are the challenges in such shot? Very roughly, I can just point out we're almost always dealing with heavy geometry, lots of polygons, heavy textures, lots of actually the assets are quite large. So it's quite a challenge to render that on a single machine. So also it has to be animation ready. The setup has to offer a flicker-free animation, be it in the GI or in the noise, wherever. You have to make an animation that feels and looks good. Also, there are volumetric effects that are going to be rendered in our shot. We have an explosion later. I'm going to show it in just a couple of seconds. Which are pretty heavy stuff for rendering, and that's also a difficult thing and challenge when rendering these kind of effects. And it has to be compositing friendly, since the output of the rendering goes straight into the compositing pipeline. So you have to supply the compositor with all the passes that are needed, with the most efficient renders that can help, or either this might be you finishing your own project in compositing software. So that's very important to be as compositing friendly as possible. So I'm going to start up with the initial step, which is actually the geometry. Let's take a look at the scene. So here we are in Maya, and let's take a look at our scene from the perspective view. That's actually the shot. So this is the standpoint, or actually the point of view. Actually, let's take a look at the animated camera. So we start, oops, let me play the animation actually. So that's going to be the shot, and here we can have, we will have an explosion. Let me select, I have a rough preview of the explosion in the viewport. It will take a little bit of time to refresh, since I'm using volumetrics caches, which are slow to read. So basically that's our shot. So what we have is a couple of things. First off, let's take a look at this thing in the viewport once more. If we take a look, we have built this scene entirely from the point of view. We don't necessarily need to model everything that we don't need to see. So you always have to keep in mind your poly budget. And we are already around, we're already around 2 million of triangles, 2.3 million of triangles, which is already a bit heavy. So what we can do in order to optimize this thing is, of course, after modeling, texturing, and the usual process, we can, well, I'm going to start with the renderable curves, which are actually a new feature of 3.0. And since I have created a couple of curves right over here, which I wanted to be cables, I didn't want to extrude those into explicit geometry. So what we have here is, by the way, this is a new feature of V-Ray 3.0, and that's a specified shelf for the V-Ray, which gives you access to the most commonly used features, such as, well, in this case, this is the renderable curves. So it allows me to create, well, either a renderable set, can you see good? Okay. a set for of curves which are going to share similar properties, or individual curves. And in this case, I can assign a material, set up the tessellation, and set up the width. It can have a variable width, but you will see this by yourselves. The important thing here is that my viewport is not being cluttered with the additional geometry, and I'm also keeping the flexibility of, if I want to change the shape of the curve is going to be done at render time by V-Ray, and you will not see it in the viewport. So no cluttering, and you don't have to re-extrude it every time you want to change the shape or the width or whatever. And it doesn't waste any computer resources. So next thing that I want to show you again is render time subdivision, which in this case is the really important thing is that it's view dependent. Now, let's again switch from the camera point of view. If we take a look at the shot, this object is really close in the beginning, and then when the animation moves on, the camera flows away from that piece of geometry. So I would really want this to be really dense in that shot. I can see here the low poly part. It's not very well defined. So I would like to smooth this out when I'm closer to that. And then, because when I zoom out of that, I don't need this geometry anymore. So this is where we will utilize this the render time subdivision. So for this thing, you can just select the object or a set of objects, and then in my case, I have applied custom V-Ray attribute, which is V-Ray subdivision, and then gave it the controls for the subdivision. And it pops up here at the bottom. So I can have it render as a renderable surface, which means exactly what it sounds like. This is going to be subdivided only at render time. So in the viewport is going to be the low poly version of that, but when I render, it's going to be really, really smooth. And to prove my point, I'm going to render. So while I'm rendering, I'm going to explain the second part. I have it turned on, switched to the view dependent mode, which actually will measure or will say how detailed this will be. As you can see, this is now smooth. There is absolutely no edge here. By the way, I'm using a new, yet another feature of V-Ray 3.0, and this is the progressive image sampling, which will give me the result of the rendering immediately, and then as time goes by, it will keep constantly refine the image so that I can see, if I want to spend more time rendering, I can see it better in better quality. So the view dependent thing, this will compare the edge of the polygon depending on the view, meaning in pixels. So if in my case, let me zoom a little bit. In my case, I have set it to 40 pixels. So if any polygon edge is larger than 40 pixels, V-Ray will try to subdivide it, and that will happen in render time. Let me demonstrate how this looks like by applying. And this is a good thing that you can use for yourself. I have created a V-Ray edges texture, and this will show me where the subdivision is taking place. I'm going to render just a small portion. Actually, let's scroll further more in animation. I'm going to render just a small portion of the render so that we can see it faster. So the V-Ray edges texture is going to shade the edges or put a small wireframe on my edges. The cool part, however, is that I can display the subdivisions or the subtriangles, and in just a couple of seconds, let me make this larger. So you can see here we have a bit larger polygons, and here as we go further away in the distance, a bit smaller polygons, and as we go further away in the distance, these polygons become larger and larger. This is kind of a LOD thingy, level of detail, bringing it closer to the camera and away from the camera, varying the subdivision. So this is really useful since the less polygons you're creating, the less memory you're going to use, the less CPU power is going to use, and your renders are going to become faster and with the necessary amount of detail. Okay, so I'm going to get rid of that. The edge texture. Okay, so what's next? Okay, the proxy. Proxy is a way, for those of you who don't know, is a way to cache geometry on the hard drive and not store it in the RAM memory of the computer for rendering, but read it directly from the hard drive. And this is very memory efficient process in V-Ray. So for example, for these columns or whatever spaceship columns floating in the air behind, I have created proxies since they are going to be far away from the camera. And I would like them because they are quite heavy. And let's take a look again at the perspective viewport. Zoom on that. So this is just a visual representation of what the object looks like. There is an option that I can show the mesh in its entirety, in its original state. It will take a little bit of time to load it up and show it in the viewport. But since, again, I don't want to clutter my viewport since I want to animate faster, you can see how much detail there is, and and this is going to be static. So I can save that on the hard drive and offload that so that I can render it faster and easier. So again, I'm going to turn it off. A cool thing about the V-Ray proxy is actually that it allows you. Probably I should turn it back just a little bit quicker. It allows you to save animated meshes if you want to. You can play them back at different speeds or loop the animation or whatever. And we have mesh visibility list, which actually allows you to turn on and off parts of the V-Ray proxy, which is really neat if you want to make variations. So, for example, you make just an example, a neighborhood of houses, and you can switch on and off different houses in the neighborhood. Just a wild example here. So, yeah, for example, I can turn on and off. But since the geometry is quite heavy and I'm running that on a laptop, now you can see I can turn on and off parts of this image, parts of this object. And this is what's going to be rendered. Okay, so I'm going to turn this off because I want and bring that back to its original state. And I have duplicated this a couple of times in the background. So what's next? Okay, yeah. So we found a couple. Actually, those were a couple of ways to offload the geometry in my scene so that I can render it without dealing with that in the viewport. The next step naturally is the shading part. So here's a couple of already industry standards. The first thing is when I modeled all the things, I made sure that I offset my UVs so that I can utilize the UDIM texturing. That's a technique used in Mari, in Mudbox, and if you want to do, you can do it by hand as well. So that's texturing that allows you to offset the UVs. So for example, if you take a look at that ship here, give it a couple of seconds. Okay. So if we take a look at the UVs, where are my UVs? Probably on the other screen, yeah. Sorry about that. So if you take a look, the UVs are scattered all over the 0, 1, 1 and 2 space, 2 and 3, and so on and so forth. So for each of these squares, we can load a different texture. But if you take a look here, I'm loading 5 textures just for the ship. This gives me quite a resolution for that without having to load up huge files. However, this will require for me to create 5 file loaders for the diffuse map, 5 file loaders for the bump map, for the reflection map, and so on and so forth. So you can easily see that just for one shader, you can have around 20 textures, 20 file loaders. So in order to alleviate that, we have incorporated the UDIM technique, which will actually, let's take a look at the shader of the ship. Okay. Oops. So here it is, and it is very easy to use just by, oops, not that one, just by typing the UDIM token in the file loader of Maya. So this way, V-Ray will take a look at all the files necessary to load and be there. Doesn't matter how many they are, they all will be loaded by using just one file loader. So that's alleviation here for you. Also, tile DXRs. We do try to use TIFF images, tiled images, which can be TIFFs or EXRs. Most of the cases we try to use the EXRs. What's so important about the tiled images? Well, these are images that can be, you can think of them as composed of smaller images or small squares of images, which can be loaded only for the parts that is going to be rendered. So you don't have to load the whole, for example, 1 gig of texture inside of your memory. You can just load the small square where that is needed for the current rendering bucket. And we provide a tool for you to convert any of your image. Since only TIFF and EXRs can be tiled, you have to convert them into tiled images. So we do provide a tool for that. So if you go into the chaos group folder, and depending on your installation, you will have a tools folder under the V-Ray for Maya, for example, here. And there is a tool which is called Image to Tiled Multi-Resolution EXR. And it has an interface that will allow you to convert all of you. It can batch convert or a single convert. It doesn't matter. You can set up different settings for you. And this you will take advantage of the tiled technology, of the tiled workflow as well, tiled images workflow. Also, that was regarding the texturing. Now, if we take a look at the shaders, oops. If you take a look at the shaders, you will see that I have made heavy use of the V-Ray blend material. For example, even in the ship here, I'm using a layered shader, which is the V-Ray blend material. Basically, that's one of the strongest shaders in the arsenal of V-Ray, because it allows you to layer several shaders one on top of each other, and it will allow you to create very, very complex, simple and complex effects, whatever you need. And this is going to be photorealistic and obey the physical laws, which is more important. So, for example, in this case, I have the Viper base, which is just a simple shader with a little bit of diffuseness, diffuse layer and a texture in that slot, and then I have a blue. Actually, let's render here. I will disable the rendering of the simulation. Yeah, okay, I have disabled it already, because it will take quite some time to render. Okay. Just update the frame a little bit, and we'll be rendering in a couple of seconds. Yeah, I've kept the region, but anyway, you can see we have a blue line passing through our ship, and that's on a separate layer, just as if it's going to be this is the way you will do it in real life. I mean, you will have a base paint and then using a mask you're going to paint a blue line on top of that. So this is why I have taken on this physical approach to layer. If I want it to look real, I have to make it the same way. And then we have a coating layer for the reflection, which is also the finishing paint, which is going to give the glossy reflections on top of that. All of these are blended using different textures, which are painted by hand, and this will give you a really natural looking result at the end. Okay, so usually I mentioned V-Ray, the V-Ray proxies. Since they can have multiple objects inside of them, and each of these objects can have different shaders, the way to manage the shaders of this proxy, these proxy objects, is by using the V-Ray mesh material. And to show you that, I'm going to select really quickly one of the columns here in the sky. This one, for example. Take a look at the shader. Oops, Maya froze. Come on. I'll give it just a second. I don't know what happened. So yeah, the idea is that you can, okay, here it is. You can, you have this shader applied on the proxy, and then it will see how many shading or how many shaders were there when creating the proxy. So you can hook up different materials on these in these slots. So you can safely assign different shaders on that if you don't want the original ones. And if you want to, for example, in that case, I have assigned a new V-Ray light material on this, on these parts. Oops. Probably I can't see them here, but if you take a look at the original one, or for these stripes here, the light emitting stripes, I have assigned a different shader on that so that you can see a glowing effect. Okay, so the next one, a really important part, speaking about the light material, a really important part about this is, if you take a look at the shader, it gives you control over what color of light you can use. I'm using a physically based approach using temperature in kelvins, which is the method that I prefer, but you can also use just a color. I gave it intensity, and a very important thing in that part is the direct illumination tab here. If I turn that on, I'm not going to rely on the GI calculations to see the effect of the light material propagating light in my scene, but I'm going to emit, or actually V-Ray is going to emit direct lightning for each and every mesh that has this shader applied. This is not going to be GI. And this is really cool thing, because I'm going to show you why in just a couple of seconds, but this is really important thing when optimizing your scene for rendering. I'm going to turn that off for the moment. So the next one, for the next bit of shading, is the environmental fog and the volumetrics effects, which I'm going to explain how I did that in just a couple of seconds. Now for the environment, I wanted to make this this fizzy feeling, or give it a haze in the distance. So in the environment tab, I have created a V-Ray environment volume here, and it's just environmental fog, which is a shader that gets applied with V-Ray. It's ray traced, and it will take into consideration all lights in your scene. I'm not going to explain that much of it. I have just created I'm going to show you a bit later on the path that I have rendered with that. I rendered it on a separate path so that I have control later in post. but that's the shader that I used. Next, for the explosion, here, I have simulated that in Phoenix. That's another rendering, another plugin developed by Chaos Group, and it's for simulations of fire, smoke, volumetrics, and liquids as well. In this case, I used for the explosion, of course. The reason that I used Phoenix here was that, well, actually, a little bit of forward before that. I can use a new feature in V-Ray 3.0, which is called V-Ray Volumetric Grid, which allows you to open up the open VDB standards for volumes, for simulations, which can be brought from external software. It's an open standard, but and it also supports Phoenix. However, in its current state, it doesn't show you GPU preview in the viewport. So this is why I used a Phoenix container or the Phoenix plugin here, so that you can see that in the viewport. I can increase the quality of the preview here, so that you can see it a little bit better. But this will give me much better preview in the viewport, so that you can see it, guys. But it doesn't matter. I could have safely used the V-Ray volume grid. So you don't. My point is that you don't need Phoenix in order for you to open up external volumetrics and render them. Okay, so for that part, I have loaded the cache here, and it takes quite a little bit of time to load up, because it's a couple of 25 gigabytes, I think. So yeah, it's quite dramatic, but it's worth it at the end. Now, the interesting thing about that is I have decided to hide this thing for the original rendering and render that on a separate layer, so that it will give me more control when compositing. However, a really important thing for this explosion is that it emits light, and it has to illuminate my scene whenever I render, and I can't do that in post. So a really easy solution for doing that here is, and that's available again in the volume grid in V-Ray, is you have the ability to simulate lights based on the intensity of the volume. So V-Ray will actually create actual lights which are going to illuminate the scene directly without relying again on the GI, which is really convenient, because and again, I'm going to explain, this is really very much related to the direct illumination part in the light material. And I'll come to that in just a couple of seconds. So that being said, let's go to the lighting and shading. Now, for this case, I've chosen to use image-based lighting. I have a texture, and using in combination with the dome light that V-Ray supports, that V-Ray provides, is actually, I'm not really sure if you can take a look at that picture from here. Let's take a look from, so where's my environment? Okay, here. So that's my texture. That's the HDR that I was using as illumination map. It has high dynamic information, so I just plug that into the dome light and use that for lighting. So it gave me quite a good result. I even got I composed that myself, so it's not the best starry sky in the world, but it does the job. So I rendered that with the dome light, and yeah, it gave me mostly almost the feeling that I wanted to. However, again, I needed to have a little bit of control. So what I did was actually created a couple of lights here and there to fill in just a couple of volumes. For example, I needed some more illumination below that bridge over here, a little bit of light inside of that tunnel. So I just created the simplest source in V-Ray, the V-Ray rectangular lights, which does great job for just for almost every situation. And with combination with another source, simple source in V-Ray, these spherical lights, I have also created the small red lights here and there, simulating, you know, plane runways or whatever. Yeah, just giving it a little bit of more interesting look. If we take a render, if we make a render somewhere, I don't know, around here, and let's actually disable the region, make sure, okay. But you can see the lights even here. So while this is rendering, let me just, okay, so I mentioned the direct illumination thing. By the way, a new feature of V-Ray 3.0 is this one, track miles while rendering in the progressive mode, which will force the samples to where, for example, when I see that here is a little bit noisy, I can just place my mouse over there and all the computing power is going to be focused on that part. So I'm going to see it better only in that area. So if I want to refine some part of the image, I just place my cursor over there. Anyway, so as you can see, all these lights here and here and here are spherical lights, which I place here, and the filling volume lights also were created just without the image-based lighting. Now, the next important thing in order to become a photorealistic rendering, or to get closer to the photorealistic rendering, is for me to use GI. In this case, we have always been rendering with GI because I did something called GI caching before that. And the GI caching is, yeah, let me tell you just a couple of seconds. V-Ray has numerous, actually a couple or a set of GI engines which will allow great flexibility for different scenarios, for different situations. In my case, I have selected the irradiance map as a primary bounce and the brute force as a secondary bounce, so that, well, in this case it was most relevant. I'm not going to have the time to explain exactly why, but you can come by later on and I'm going to explain. Now, the cool part about the irradiance map is that it allows me to cache the GI so that I can render it first and then reuse it for each of my subsequent renders, which is a great help for me when adjusting the shaders and adjusting the final rendering. Also for the final rendering, of course. So what I did, however, a very interesting thing here is that for the GI to be calculated really quickly, I discarded or removed from rendering the moving objects, since I had only one ship, actually the ship that was dropping the bomb here in the beginning, and a couple of lights here. The beams are also animated, but the rest of the scene, and of course the explosion, but the rest of the scene is static. The camera is the only one, the only thing moving. So we have a way to render only one image, which is for all the static objects, and there is a way for you to take into consideration the camera movement. So if you take a look at the irradiance map settings here, we have the use camera path option checkbox, which is turned on. So this will take into consideration all positions of the camera and render GI for all these positions. Then save this GI, and I will safely have all the static geometry baked into one map. And I rendered this only once, but I have 120 frames of animation, so I saved 120 times rendering the GI. Also, for the rest of the part which was not animated, there is a way in V-Ray to pre-calculate the GI only for these moving parts, so that you have proper GI solution. And because that moving ship is just around, I would say, 10% of my image, really small amount, the rendering will not be will not be compromised. It will be again very, very fast, since just a couple of pixels are being re-evaluated. Now, let me show you how. So I saved this irradiance map. It's on my hard drive. There is a way for you to check how your irradiance map looks and to see if there are enough samples or if the quality is really good. Again, by relying on our tools folder, there is a tool called Irradiance Map Viewer. So if I open that up and go into my folder, in the assets and the GI, here is my cached GI solution. Open that up. And if I reset the center and center that up, probably my scale is really, really large. Let's reopen that up. Okay. Yeah, I guess my scene is really, really large. So you can navigate here and take a look at the samples in our scene. Oops. If I zoom out a little bit. Well, here is something that it's good to know. Since my scale was really, really large, my scene was really large, now the viewer is giving me a little bit of headaches. So yeah, I'm just going to close that, not waste any time on that. But you can see your, the point is that you can have a look at your irradiance map first and decide for yourself if you need a higher resolution or a better quality irradiance map. And then, as I said, you just reuse that irradiance map to re-render and render really fast. Now, so yeah, this is how we optimize this thing. And the final thing that I wanted to mention and make a connection with the direct illumination is that by making sure that our lights are illuminating direct our shaders and the simulation or the volumetric effect is emitting direct light, I'm making sure that it doesn't participate in the GI, so that I can rely on the direct lighting to illuminate my scene. And because I have already cached the GI in one frame, I don't have the animation of the illumination inside of that. But when I turn on the direct illumination, I'm fixing that thing, and it becomes really, really easy to render. Okay, now then we move to the almost final step for the rendering and animation, for the rendering of the animation. So what we need to consider are a couple of things. The first one is the resolution that you're going to output. So I always prefer to render with a bit of overscan, render a couple of pixels more, so that I have just a little bit of freedom, and then do the shake in post. Because we have an explosion, it's much more convenient for the camera to be shaky. However, if I animate the camera to be shaky and render that, this will not give me any freedom for if I want to change the shake later on. So this is why I'm extending over scanning the image, render a bit larger resolution, and then doing that in post. Then the very important thing you have to consider is your render output. The importance of the output is, or the importance of the float precision is, well, OpenEXR is something that we support. In V-Ray 3.0 we support OpenEXR 2.0, which supports deep images. All of these things give you much more control into post. The good thing is that you have floating point precision, much more colors in this image. You can have high dynamic range information. Deep versus Z-depth, that's a thing that you have to consider. The deep images are going to give you information about the depth. However, it will give you information about overlapping pixels. especially at the borders. So you can render volumetrics, you can have actually deep images with information of pixels behind each other, which is really, really, really cool and really convenient in compositing. However, the size of these images can become really, really high, and then this can make your compositing process really slow. So it's always, you have to make decisions, tough decisions about the output. And then the file size considerations, of course, again, larger files and deep files can slow down your compositing process. So for the final thing that that I want to address in the rendering is to make the life of the compositor after you much easier, so that you can render your passes or all the render elements in V-Ray, or the passes here will allow you to split your image into basic modes or into basic layers, such as the diffuse, the lighting on a separate layer, the reflections, the refractions. All of these parts of the image and the shaders can be extracted on a separate layer. However, what you can do also is to extract utility passes and masks, which will again make easy selection of different parts of the image later on in compositing. And oops, and what's left, the final thing is, what I'm left with is the compositing part, which probably I'm not going to have time to show that to you, but really quickly, or for what we have time, is I'm going to show you the final result. So that's PD player. So this is what we have. After final compositing, yeah, this is everything that you saw rendered and composted with a little bit of color grading and one or two glows here and there. So what did we do here? What did I do here is, if just I take a look really quickly at my final compositing. So this was my original input. We can take a look at the numerous, where's my page down? Okay, passes that I have. So here are a couple of masks, the raw GI. This is my environment background, which I can replace if I want to, or color correct. Here are the masks that I was talking about. So different parts of the image are on separate render masks, so the beams, which will make the life of the compositor much easier, as I showed you. We have camera normals and so on and so forth, UV for remapping. So yeah, these are all the passes. One of the passes that I wanted to stress upon is the self-illumination, which gives me contribution of all the lights here. However, I have a light select render element which will extract the lights and the contribution of a specified set of lights, which can allow me to change these lights later on. And to demonstrate this, let's take a look at the final image. Okay, the RGB. Oops, that's the explosion. Let's take a look at something before the explosion. Something right here. Okay, we just a little bit more. Yeah. Okay, anyway, so here we have the slides, these lights here, and if I adjust their contribution, just a second, here's my fog, smoke. Yeah, I can't seem to find this right now, but I'm just in a hurry. So let's take a look at the passes separately. I wanted to show the fog here, which I can grade if I want to, so make it more contrasty or less. So add this together, give it a bit of actually give it a bit of a kick right like that. And by splitting all of these things into separate, here's my rocket, which with the appropriate flare looks much shinier. So if you take a look at the rocket without the layer, it's just something like this. Okay, without the flare. And here I have the explosion, which will give me, it's not there yet. So here's the explosion. I have color corrected that. I'm applying a velocity-based motion blur in post, which is much cheaper to calculate. But again, it's always you have to make considerations before relying on this solution, because if you have objects that are moving and are passing one in front of the other, this solution might not always work fine. So in this case, I have mostly camera movement, which is very perfect for that shot. And so at the end, we got up with something like this. And the final shake, as I said, done in compositing, which will allow me much greater freedom. Now, I think we'll have to wrap it up. Just make sure that you stay around for the draw. I would like to finish up with, I really hope you like what you saw. I'm going to finish up with by saying that tomorrow I'm going to make a presentation about what's new at Chaos Group, the new things in the upcoming, in the recently announced V-Ray for Modo and V-Ray for Nuke. So we are trying to keep up, to be everywhere in each and every platform to provide V-Ray solution. So you can just come around. So now I guess it's time for the draw. Yeah?